Okay, hello everyone. Can you hear me? Great. So thank you all for being here. I know it's a difficult time of day. It's the second day of the conference. We're right after lunch, so thank you again for being here. I hope you will find something useful in the next couple of hours. So today I wanted to discuss with you some stuff regarding messaging and how we should design our messages in event-driven architectures and, in general, distributed systems. So if we look at it from like a bird's view, from a big distance, let's say, event-driven architecture is nothing but this simple diagram. You have some kind of producer that is sending out some messages, and then at some other point, you have some consumer that will need to consume them and do something based on them, right? Has anybody worked with event-driven architectures or, in general, messaging systems? Okay, I see lots of hands. That's nice. Today we won't be focusing on the infrastructure, on the technology. We will be focusing on some patterns on designing messages and some trade-offs that occur based on these decisions that we make, okay? Now, this seems like a very simple diagram, and it is, in fact, right? And it's easy to get started with some kind of event-driven architecture, some kind of mechanism for, distributing messages and having producers and consumers all around. It's a very easy thing to do. But initially, when we start such a journey, there are many decisions that we don't really make at the right time, and they come back to bite us. So, although it seems simple, there are lots of different aspects that we should keep in mind when building these kinds of systems. Because each of these little things deserves its own, let's say, focus and its own, research. Because it's easy to, make the wrong decisions and then pay for them. Okay, so something that conceptually is very, very simple, like you have a producer and you have a consumer and you want them to somehow communicate over some kind of communication medium, can become very, very complex if we take all these aspects into account. So how do we end up in such a mess? We're not here to discuss all these aspects. We will be focusing only on the topic of message design today, okay? So, a few stuff about me. I'm a principal engineer at Kaizen Gaming. I've been through a number of roles in my career so far. I've been helping as an organizer for a couple of conferences and running a meetup since 2016 on domain-driven design. And it's great for me to have you here. So let's recap again. What's the whole purpose of event-driven architectures? Anybody?
You can learn scalability. You can learn some characteristics, important characteristics in architecture, as scalability, performance, fault tolerance.
Okay. Awesome, thanks. Okay, so the basic tenet of event-driven architectures is that we can decouple the communication between services and we don't have to do everything at once on the same machine, right? We can distribute our workloads and allow them to communicate through various messaging mechanisms, and then we can get all these benefits that our friend here has mentioned, okay? So, of course, we get scalability because we can distribute workload. Of course, we get resilience because it doesn't really matter if some instance of our application or some server is not up, someone else will take the extra work. One of the basic things we achieve using these kinds of architectures is what we call loose coupling. So in essence, when we have a service that is producing some messages, it doesn't really need to care about who will consume them. And it's not really necessary to have everything run synchronously. We get this kind of loose coupling, okay? This comes together with what we call eventual consistency. This means that for workloads where we don't really have to, it's not really mandatory to have the latest snapshot or the current state of the whole view of the world, and we can make some decision for some business action based on the information we currently have, this can actually unlock the rest of the other characteristics, the rest of the other benefits. Without that, we can't really achieve any of the other ones, okay? Now, this can also be a problem as well, because it's not really applicable in all kinds of workloads. Plus, it all comes with extra complexity. It makes difficult to debug our systems because in the past, when everything was running on a single machine, you could just, run it on your local IDE, put a breakpoint somewhere and see what's going on. Now that you have multiple systems interacting, it's not really easy to keep track of what's happening, okay? So, and we also get lots of other issues like if there are ordering guarantees in our messages and we need to process things in order, this creates a lot of extra work and possible risks. The good thing about eventual consistency is that sometimes, for some domains, even if we don't have the latest state, even if our view of the world is not really as things are in the real world, we still can proceed and do some actions and process some workloads. For example, if there is an extra booking in a flight, or if there is an extra a double booked room in some hotel, it's something that, okay, we don't want it to happen, okay? But really, it's something that we can work with and we can, let's say, compensate for via some kind of business rule. For example, if there is an extra booking for a flight, the airway can send you on the next one, or they can give you a refund, or if there is an extra double booking for a hotel room and there is no other room available, you can just, go to the next and they will pay for your room or something like that, okay? So let's not get trapped in, as engineers, we sometimes want to have like everything working perfectly and have like everything in sync. It's not really feasible. So if we can fix things from the business side, let's take that as an advantage. Okay? At any point in time, you can interrupt me for questions, or we can discuss in the end. So, yeah.
So regarding eventual consistency, the last example you gave with double booking, wouldn't that be resolved eventually, like in the sense of the double booking would vanish and you would have only one booking?
No, I mean, we could book the same room for 2 customers at the same time.
Yeah.
So then if the hotel can't accommodate you in a different room, they will need to, make arrangements with the hotel next door, and they can perhaps, accommodate you, stuff like that. Or they can pay for you to go to a different hotel or something like that, okay? So, all our discussion today will focus on messages. But what is a message? Anyone?
Maybe like a structured data information that we pass from one system to another.
Okay. In a more generic view?
Yeah, a piece of information.
That?
This is what I said.
A piece of information about what?
About something.
Like?
I don't know, an event or something.
Okay, an action, okay. Okay, if we go back in the past, when I still had hair, and we would still send letters over post, I don't know, maybe some people still do. Actually, a message is like a letter we send to, I don't know, someone, okay? So it is the mechanism that allows things to work asynchronously. We create some message, we wrap it in an envelope, we send it over to the post office, and somehow it will end up in some recipient, okay? Now, overall a message is this kind of, let's say, package of information that needs to travel from one location to the other, okay? And in computer systems, we have different types of messages. The basic kinds of messages we will be talking today about are commands and events. So, a command is something that represents an action that we want to perform, like some operation, like booking a room, okay? Or reserving a hotel, or a flight, or whatever. It contains information about something that some action that we need to complete, okay? And it usually has a single sender and a single recipient, okay? So it's a point-to-point kind of communication. Now, anyone working with CQS or CQRS? Okay. I will not be talking about queries. If you know what queries are, then, those of you who have worked with CQRS. Some people like to also consider queries as messages, but for the scope of this discussion today, we won't be talking about queries, okay? We will only be talking about commands and events. Now, the difference with events is that events represent something that has already happened. They contain information about some business process that took place, like the fact that a flight was booked, or that some invoice was issued or something like that. So it's always something that has happened in the past, okay? And we may need to, let's say, broadcast this information to anyone who is interested, okay? Now, some people like to carry the full state of their system through events, so they expose all information related to this operation, and this is what we call event carried state transfer. But this is not always necessary, it is not always the case, okay? So in any let's say, way, by events we refer to any kind of information that tells us that something has occurred and some other, let's say, systems or processes or people need to know about it, okay? So if we want to look at it in a more, let's say, graphic perspective, this is the kind of the things I'm referring to. By commands, you have like a system A that wants to somehow communicate some kind of operation that system B needs to perform. So it sends out some message, some command to it. Now, this command might either travel directly via a synchronous operation like an HTTP call or an RPC call or something like that. Or if we want to be able to scale and run things in parallel, we could use some kind of messaging mechanism to store these commands that represent jobs to be done, let's say, to some kind of queue or something like that if we need ordering. And then eventually the target system will receive them, consume them, and do whatever needs to be done, okay? So it's not synchronous communication. It's not like an HTTP call or an RPC call or whatever, okay? Now, the difference with events is that something has happened in this system that is producing some event, and it's trying to notify anyone interested that this has happened. Like, for example, if we imagine an airway company, okay, we can consider this part to be like the service that is letting us know that some booking has been confirmed, and this event would be propagated to other, let's say, parts of the business that need to issue invoices, arrange for the catering for the flight, or whatever, okay? So this mechanism allows us to distribute this information, and not necessarily the same information to all recipients, okay? But it makes it easy for those interested, for events that have happened, to subscribe to them and react when needed to perform their own operation, okay? Now comes the basic question of today's discussion. So what do we put in a message? What kind of information does a message need to contain to achieve its purpose? Let me hear from you.
For a command or an event?
Any kind of message, either for a command or for an event.
Probably the information regarding what happened. Let's say the order number or the booking number, the timestamp,
Okay.
what happened, maybe
Okay.
who triggered it, or maybe let's say
When you say who triggered it, you mean by a person or a system?
a system or something like that, like a tracing or a trace ID maybe. So you have distributed, let's say, logs with the same key, so you can find what happened when or something broke in between. And it's obviously other kinds of things.
Okay. Someone else wants to add to that? Okay, don't be embarrassed. Yes.
The action that happened on or that we want to happen, if it's a command, what we want to do,
Okay, so the type of message, let's say.
the type of message.
Okay.
I think it depends what system you are designing.
That's the right answer. Okay,
So it depends on your domain. What is needed?
of course. Okay. Okay. Okay, but we're interested in, any ideas on what kind of information needs to, be carried around in such a mechanism, in such a message. Okay, thank you. You were all to the point. As our friend here said, it all depends on our domain. It all depends on what kind of architecture we have in our system. Okay, so if we're talking about a single application, a monolithic application that works on the same machine, nothing like that is necessary. Okay, this kind of communication would be achieved by a function call or something like that. Okay, these are mechanisms that we use when we need to spread out the workload in different systems, or we need to communicate with external parties like third-party vendors, APIs, stuff like that. Okay. Okay. To discuss with these, on these, let's say, aspects of how to design a message, I will be introducing an example related to a fictional, let's say, social media kind of system. Okay, we have some very basic entities. You can, imagine it like, I don't know, Instagram, Twitter, whatever kind of social media you're using nowadays. So we have some basic entities here, which are our users. Our users can create some kind of content. They can upload a post, some photo, something like that. They can also react to content that other people are uploading to our system and connect with other users, building their, let's say, their graph, okay, their network. Now, posts is the kind of content that is created by users. Comments are the responses to posts. Reactions are, all the likes, loves, stuff like that, that we, add to a post or a comment. And relationships is the connections between the users, the friends, the followers, stuff like that, okay? So, if our system is successful, if our product is successful, we can't really run all of this in a single machine. So we need to distribute these kinds of concerns to different systems. So we could have a system that keeps track of the network between users and builds, your suggestions for new people to follow or stuff like that. You could have a reporting service that keeps track of your engagement metrics, how many users react to your content or stuff like that. So typically we have many different business concerns we need to cover, and that's why we need to break up our system into many, let's say, subdomains, okay? And we want to see how these different subdomains will need to communicate between them by exchanging messages. So, I don't know if you've read the training material I've uploaded to the talk's description. There is a PDF there with a link to a repository with a sample demo that we will be going through together today. You won't need to write any code today, okay? So no worries, you don't need to use your laptop, but you can follow together with what I'm going to be demonstrating. And I will describe now the structure of this project so we can all follow along, okay? Any questions so far?
Where do we do the translation?
Okay. At the moment, we suppose that we're working in the same company, let's say. Okay, all the system is part of the same system, let's say, the same product. It doesn't really matter how each subdomain or each team calls all these entities, how they translate, and what is the terminology they use. This is what we refer to in domain-driven design as the ubiquitous language. Okay, so each domain, each, let's say, part of this company that deals with a specific aspect of all this stuff can have its own terminology, and they will need to translate the messages they receive or need to send from the external, let's say, systems language to their own, okay? But this is not really in the scope for today's discussion. We can discuss later if you like. Okay? Any other questions? Yeah.
I have another question about a slide you had before with the command and events.
Mm-hmm.
And yes, the next one, sorry. Can we have systems that can take commands and then do their work and produce events, and the others, for example, the system B, C can do a command?
Yeah, of course they can also publish their own events. Yeah.
That's
Yeah.
the idea.
Yeah.
Right?
Mm-hmm. So any kind of system that needs to broadcast some kind of information about something that has happened in its own domain, let's say, can broadcast its own messages. But what I'm showing here is that the fact that events are not really directed to a single consumer. There may be multiple consumers that need to know that something has happened. Like, for example, as I mentioned before, we can have multiple teams in a company that need to know that an order was placed. You need to have the shipment involved. You need to have the let's say, accounting to issue the invoice. You could have like the inventory. Lots of different departments that need to be aware that an order was created. Okay.
Reservation, let's say.
Okay, that's a big discussion because there are many things that can go wrong in a distributed system, as the one we're discussing. For example, if indeed some system handled this command about this event, about the booking, you could maybe there was like a duplicate message. Perhaps the operation was retried or something like that because yeah, there are ways to handle that.
Based on the hotel or the floor of the room?
Of course, there are ways to tackle these kinds of issues, but I mean, we won't be going too much into that discussion today, okay? But of course, these are all scenarios that are real because distributed systems are hard and all these things happen every day, okay? Okay, let me, yeah. Yeah, sure. A command could be something like a message that says, okay, I want to create this post, or I want to comment on this post, or in our scenario, or I want to, let's say, pay this invoice, or I want to book this room. Okay, these are all commands that are targeted to some system, and this system needs to respond to them, do the booking or issue the invoice or anything like that, and then it may need to publish some event that is relevant to some other department, okay? So these are all examples of we will see some examples now in the scenarios I will be presenting, so we can see these things in practice, okay? Okay, let me proceed with describing the structure of the demo projects that you have in the training material. Okay, I'm using this mic now. It's okay. Great. So, in our example here, can you see the... let me increase the size. Yeah. Better? Okay. Awesome. Okay, so I will quickly go through the structure of this demo project so we can see what kind of stuff we will be discussing about today. Now, I have split it into different areas, so we don't really have all the code in the same project. It makes it easier to keep track of the different layers and different techniques we'll be using. Over here, we have some projects containing some core stuff like command handlers, event handlers, things that will be our, let's say, infrastructure for handling these messages, as well as producers and consumers of messages. Then we have our domain. This is actually what we would store in our database. So the posts, the users, the relationships, stuff like that. okay? And the relevant repositories to access all these entities, let's say, as well as some abstractions about our events, our commands, so some interfaces that we will be using. Then we have the infrastructure part, where we do actual implementations of messaging mechanisms through various brokers. We will be using Kafka and RabbitMQ as example to show how we can, let's say, isolate our domain from the kind of messaging system that we're using underneath to transport these messages to between producers and consumers. And then I've written some scenarios which describe these kinds of, let's say, business flows. So, for example, I have some flow for creating a new post, or accepting a connection request between two users, or reacting to a notification, or let's say adding a reaction to a comment or a post and receiving some notification, and adding a comment on some, let's say, post, okay? So this describes the kind of steps we need to take to let's say, execute this kind of business flow, all right? Now, these are organized into some scenarios, and I have this CLI application that will allow us to run these scenarios. So what I want to focus on in this discussion is the different types of, let's say, the different styles in which we can design our messages, and how these decisions we make will affect our developer experience and our whole, let's say, flow and observability and operation concerns, okay? So far, so good? Great. Okay. Now, initially, when we first build a system, we typically, don't really worry about, or don't spend enough time to think about operational concerns. So we start by keeping our messages simple. We only include in our messages just the information that concerns the business. Like for a post, or for a create post command, we would have like the author or the content, the date time when it was created and stuff like that, okay? We don't really think in the first steps to introduce extra information that would be useful for keeping track of the whole flow. We just care about the business, let's say, the basic core business flow, okay? So this leads us to create messages that purely represent our domain. Since domain purity is something that we like, when we write code to handle all these commands or events, we don't really want to be concerned with details about how these messages will actually be transported from system to system, or how we can debug, let's say, a complex flow spanning multiple systems. We don't really add this kind of information there. This is usually the first step in the evolution of our system, right? We are only focused on delivering business value and building the core features of what we're going to achieve, okay? Now, this is what I call the pure style, lending the term from the, let's say, pure domain that we use in domain-driven design. This has some pros and cons. Let me demonstrate this in code so that you get an idea of what it's like in practice. So I have split, our objects here in commands and events. So for example, the create post command would only contain this kind of information, the author ID, the content, and stuff like that. This is a very simple, let's say, social system where we only have text messages, not images or something like that to showcase. And this is what we would need to transfer to our, let's say, recipient that will need to handle the reaction to a command, to a post. So we have the post ID, the user ID, the reaction type, if it's a like or a love or whatever, and when this action took place. We could have this connection request command that says, okay, I'm user A and I want to connect with you, I want to follow you, or I want to become friends with you. So I'm the requesting user, this is the target user, and this is when I send the request. So this is all just basic information that would cover our business flow requirements, right? Okay. Now, this is nice in a way because as developers, we don't really need to be concerned about, other aspects that can become troubling and that depend on the kind of messaging mechanism that we use. But it can make some things trickier. So we will discuss here the pros and cons. So for example, when we add a comment to a post, then we would somehow need to publish, when we handle this command, an event that says, okay, this comment was added. This, if you notice, I'm using the present tense here to convey the fact that this is something that has occurred in the past, and we're just sending out, we're broadcasting this information to the outside world. Okay, so we have this comment ID, the post, the author, the comment author, the content of the comment, and stuff, okay? So this is nice because we don't really need to be concerned with nothing that is not part of the domain logic, but it can also lead to some issues. So it's nice if we can separate our logic and keep our domain clean, our domain code clean, and not let infrastructure implementation, let's say details, leak into our domain code. And theoretically, that would allow us to change the kind of messaging mechanism without needing to do any changes to the code in our let's say, core libraries or our core system. Okay, because this is, if you're working with clean architecture or hexagonal architecture, this would be like the outer layer, or not really part of your domain. And it's easy to test the business flows with such kind of messages, because you only deal with the core information that is required to perform these flows, right? Now, this has some, let's say, constraints as well. The thing is that to support this kind of messaging style, I mean, initially we ignore all the messaging, let's say, the tricky parts of the messaging and the kind of brokers that we use or the mechanism we use to transfer messages. But this is something that can, lead us to lose information regarding the actual flow and give us a very good view of how things are done, especially when we need to, keep track of things that are happening in different systems, right? So it makes operability more difficult. It's not easy to correlate the fact that some event was published with the command that was responsible, that was the reason for us to publish it, right? Because we lose the opportunity, we lose the chance to, let's say, correlate these messages. And correlation is a very strong feature. It's something that we like very much if we want to have observable systems that we can reason about how they work. And usually, if this is the approach we follow, and it's typical in the first, let's say, days of building a system, at some point, someone will call us at 3 a.m. in the night, and they say, we have these messages piling up, these events are coming from all over the place, we don't know what's going on, okay? And they wake you up, and you try to figure out what has gone wrong, and you have no actual way to keep track of, let's say, the relationship between the messages that are, flooding your system. There's no way to keep track of why was this event published, what was the command that caused it to be published, okay, and stuff like that. So it's not really easy to operate a large-scale system this way, okay? And typically, as a result of this trauma, what happens is we go the other way around, and we start including everything we can in our messages. So we go to the other, let's say, end of the spectrum and try to include everything in our messages. So this is what I call embedded. It's not an official terminology or anything like that. But the idea is that we will add as much information as we can in our messages so that we're able to regain this kind of visibility, this kind of observability on what is happening in our systems, okay? This is usually the result of this kind of trauma. When you're tired of being waken up in the middle of the night and trying to figure out what has happened, it makes it easy to have messages that are self-contained and can give you quickly insights on what was the flow and allow you to connect them and build this kind of chain to see what went wrong, okay? And this also has its pros and cons. Okay, I will go through them quickly. First of all, as I mentioned, these messages are self-contained. So they have all the information we need to deduce what was the relationship between them. They carry information about what was the command that caused this event to be published or stuff like that, okay? Typically, they also make some other stuff easier, like it's just a simple object that needs to be serialized, so you have simpler code. You don't need to worry about handling this kind of information separately, because in the first case, if you want to include such kind of information in your systems, you need to have a smart, let's say, serializer or some kind of mechanism to add these, let's say, attributes that would make this correlation in a magic way. And at any point in time, you know what kind of metadata you have available. This kind of information that is not part of the core domain, let's say, we call this metadata in general, okay? And by including them in our message, we know what kind of information, what kind of metadata we have accompanying our messages. This is nice because you know what kind of information is available, but the code that typically needs to handle these kinds of messages can become very complex because besides the domain, let's say, part of the information that this stuff carries, you also need to manually keep track and update and fill in all those extra, let's say, fields, okay? And of course, metadata is also information. So at some point in time, we might need to change what kind of metadata we need to include in our messages. So this makes evolution even harder. If we want to change the structure of our messages, this means that all our messages are affected. And it can be easy to lose track and have a consistent way of adding metadata on our messages. Okay, so this leads to more difficult testing. We need to fill in this data, this extra information, so that we can test our flows. And it makes it more tricky to evolve our schemas. Yeah.
I have a question about because you're supposed.
Yes, you carry more data. So you have some overhead in terms of the actual payload that you need to carry.
Many messages, a million messages. I'm not quite sure if the performance is better or not.
Okay, typically what happens is that if you don't include this information in the message and you don't have a smart way to do it, you might.
Way to reach this information.
Yeah, you need somehow to include this information at the messaging layer. So where you interact with the broker, you need to somehow create this information so that it accompanies the message. So you need to add this metadata based on what kind of mechanisms each broker supports, like adding attributes or message properties or headers or stuff like that. And you need to do that at this layer where you actually interact with the broker. And this can increase the complexity, okay? So this is why by adding all this information and not worrying about what kind of mechanism each broker has to support this kind of metadata, you just have a payload and that's it. You don't need to care what kind of mechanism each broker supports, okay? Okay, so we can go through the code examples if you like, or we can watch them all at the end because I don't want to lose you here. I know you're tired. I know it's been a long day. So I'll go through to the next style, which is becoming, let's say, the standard nowadays. So as we saw, embedding all this information in our messages was a bit cumbersome. So we wanted to keep our, let's say, domain code simple and not leak all these concerns in our code, in the code that handles these events and these commands. But we also wanted to be able to carry this information and propagate it where needed. So what happens nowadays is that we typically use what we call envelopes. Okay, this is a pretty standard technique nowadays. So we have this kind of wrapper that includes both the business data, both the actual message that we want to transport to the consumers or to the system that will be handling some command. And we also have explicitly separated metadata, and all these two pieces of information are traveling together, wrapped in the single envelope. Okay? So this is a very, very standard technique nowadays, and it kind of combines the best of both worlds. So the good thing about it is that not everybody needs to worry about the kind of metadata that is transferred on each message. You will have someone writing all the plumbing code to somehow, extract metadata from an incoming message and add metadata to an outgoing message, okay? But the rest of the code that handles this is only concerned about the domain concerns, okay? So does it make sense? Okay. The difference here is that now our domain code doesn't really handle commands or events explicitly, but they handle envelopes. So now they have access to both the domain message and the metadata, and they can decide how to deal with them. Okay? Yeah, sure.
What is the causation idea? What's the purpose?
We will go into that a bit later.
Okay, thanks.
Again, if we choose to go with this style, we still get some pros and cons. The good thing here is that we have one message that is carrying both the business logic, let's say, related information and the metadata in the same wrapper. They are cleanly separated. Not all the parts of the code need to know about both of these, but they are handled as one piece of information traveling all together. Okay. It's easier to evolve the schemas either for our core, let's say, message, our domain message, and the metadata without affecting one another. Okay. So if we need to add an extra piece of information as metadata, or if we want to evolve the schema of some command or some event, we don't really need to touch up all the code, just the relevant aspects. It makes evolution easier. I don't know if you were in Nikhil's talk yesterday, who talked about evolvable architectures. He mentioned some of that stuff as well. Okay? And this is an explicit pattern in the sense that you know that you have separation between the actual message and the metadata, and you can decide how to deal with them. Okay? So it gives you full control. Now, okay, this can increase, you need to create more objects. It has some extra memory overhead and stuff like that. And people need to get acquainted with this kind of messaging style. They need to know that, the messages contain the actual data and the metadata and how they should be using them, because it's easy to abuse them, right? So if for example, I have decided that my metadata will contain some kind of timestamp field that gives me information about when this command or this event took place, that won't be bothering any developer to go and add a similar field in the actual, let's say, core message, right? So we might end up with duplication or stuff like that. It needs kind of a better governance and a more, let's say, strict code review or things like that. Okay? Okay, now, the envelope pattern was so, let's say, successful that recently, like a year ago, if I remember correctly, the CNCF allowed this project called Cloud Events to graduate. and it's becoming a common standardized way to express this kind of messaging style. Cloud events is a CNCF specification for describing event data in a common way. And it's just an envelope pattern where they have created this specification that defines what are the standard fields and what are the common fields that should accompany some message. And it's becoming widely adopted by cloud providers and vendors all over the world in different systems. So it's a good idea to have an eye on it. All the major cloud providers support it, and the nice thing about it is that they define, besides the basic, let's say, attributes that should accompany a message, some bindings that allow you to, let's say, map these attributes in the kind of mechanisms that each broker, each messaging system supports for translating, let's say, this metadata into the technology at hand. So, for example, if we were dealing with HTTP requests, this would become like standard HTTP headers. If we were dealing with AMQP messages like in RabbitMQ, we will have message properties. For Kafka, we would add this information as metadata, as headers again. So there are plenty of libraries and SDKs available for various programming languages. And it's really, I'd say it's a good recommendation to, if you haven't already adopted them, to keep an eye on them. Okay, so there are two ways to represent messages in cloud events. The one is the structured mode, in which case the entire event, the attributes and the payload are encoded in the message body. And the other is the binary mode, which is more flexible in the sense that it's not enforcing some specific structure. You can have like only your payload in the message body, and the attributes, such as metadata, are stored as part of whatever its broker supports or its mechanism supports. Okay? Now, I won't go into more details on that, but let's go for a quiz. Okay. Let's see what would be the best style to choose based on some scenarios. So, let's suppose that we're dealing with a case where we want to have like pure domain code. We're doing domain-driven design, perhaps, I don't know, if we're lucky. Or there is some experienced platform team that can support all these, let's say, infrastructure concerns and provide us with a decent observability experience. And perhaps we all use, in all our teams and all our systems, we use the same broker, so we don't really need to deal with multiple vendors, multiple tools like Kafka, Rabbit, SQS, Event Bridge, whatever. Okay? Which style would you choose?
Yeah, pure.
Okay. Anybody else? Okay. It makes sense to go with a pure style in this case. Okay? So it's just bare, simple domain stuff, just the meat of our domain logic, of our, let's say, the information we need to communicate. Okay? So, next case. We have a simple system with, metadata that doesn't really change. We know what kind of metadata we want to have in our system. Or we may need to include, let's say, information that accompanies the message throughout its entire flow. For example, this is a prime example of this is routing slips. I don't know if any of you is in the logistics domain. You know what a routing slip is? Ever received a package from Amazon with all these stickers on top from different, let's say, barcodes and all information about the processing centers that it has gone through? This is what the routing slip is in practice. You have like this kind of piece of information that's accompanying each message and is updated as this package moves along the system, okay? So this allows us to make decisions on each step of the way. Now, in such a case, which style would you go for? No one? The embedded, okay. Exactly. Just put everything in, okay? Someone asked if there would be tzatziki in the lunch. Anyway. Okay, so in this case, it's easier, or maybe it's more practical to include all the kind of information we need in the same message and have them be self-contained, right? And of course, you might have guessed the answer for the third one. Okay, in the cases where we have complex systems, where we have frequent evolution of the schemas of the metadata, or we may have multiple teams working with different technologies, and we need somehow to translate messages between different brokers or stuff like that. And we need to have very fine-grained control on all this information. Of course, you would guess the envelope, right? So we have some kind of wrapper that wraps the meat of our, let's say, message and the source, the metadata. Now, since we're in Thessaloniki and it's getting a bit late, I needed to adapt the presentation a bit. So yeah, it's the same thing. What is actually an envelope with some nice payload, okay? And some stuff sprinkled on top. So this is a case where the envelope pattern would be more, let's say, fitting and would give us more flexibility, okay? Now, questions so far before we proceed? We're going to the causation stuff in a moment. Yeah? You mean releasing to production? Well, it's all a matter. It all depends on the kind of maturity of the team. I mean, essentially, none of these is better or worse in terms of how fast you can ship. The thing is that some of these are more, let's say, convenient if you need to keep track of business flows that are very complex. I mean, it all depends on the evolution stage, let's say, of your system. So, okay, and the maturity of your team. If you have a very good team that supports your DevOps operations and your operations and can provide you with some kind of observability platform or something like that, perhaps you can get away with pure messages even for a more complex project. If you don't, at some point, introduce these kinds of support mechanisms, it's going to get more and more difficult to push things to production, okay? Okay, now, you may have noticed that, even though we didn't go through the code examples in detail, it makes sense that all these different styles lead to, let's say, richer or thinner messages. Now, again, this is another spectrum that we need to decide where we want to, at which point we want to stand. Like, let's say the embedded style is more convenient when we want to go for fat messages that contain lots and lots of information, actually as much information as we can. This may not always be desired, okay? In some cases, we would prefer our messages to be thinner, only contain critical information that is enough for the rest of the world to know that something has happened, and perhaps if they need to, they can request extra information at a later point in time, okay? Now, the extreme end to that is clickbait events that only tell you that something has happened, but don't give you any kind of clue of what really is going on. For example, you may have seen all these notifications popping up in your mobile phone that says, okay, you have 2 notifications on Facebook, or you have 3, let's say, friend requests on LinkedIn or whatever, okay? So, I mean, unless you open that application, you don't really know what's going on. These are just, as I mentioned, they're called clickbaits because you actually need to open them and go to the system and see what's going on, okay? And again, depending on which style we choose, this may have an impact on our system because, for example, if we're trying to, if let's say we have this event that needs to be propagated into another of consumers, then if all these consumers need lots of information to perform their actual task, if we don't include it in the message and we only send out a thin message or a clickbait event, let's say, they will need to somehow do an extra HTTP call or somehow retrieve this information. So we will be practically, especially as the number of consumers for a message is increasing, be DDoSing our system. Okay? It's really easy to fall in this trap. On the other hand, pushing out everything, all the information with this message, can lead to other dangers, where you actually expose lots of information about how your system works. And this is not really desired, because then, from the moment that you publish something out there to the world, everybody can just become coupled to your schema, to your definition, to the information you're publishing, and then it makes it more difficult for you to make changes. Okay, so if at some point you change how your system works, and this is the extreme end of that is like actually publishing your database as events, okay? The full state of each entity can be, there are cases where this has happened, and it really makes things difficult to evolve, because at some point you get people that are coupled to your schemas, okay? So, again, also, for example, another dimension that plays a role here is the staleness requirements. So if you want real-time updates, it might not be the best idea to include the entire information in a single event, for example, okay? Because typically then you would go with a mechanism like deltas, like messages that are applied one on top of the other, and allow your consumers to rebuild the state on their side on what is going on with some entity. But if you want to do some kind of reporting or batch processing, you don't want to access any extra databases or do any other HTTP calls when, I don't know, when you need to process all the transactions of a single day. If you need to ask the database, to make a query to the database for each one of these, you're missing the whole point, right? So it's a matter of balance, again, on depending on your domain. Plus, all these messages have some, let's say, weight. They have, they're transferred via some kind of communication channel, so they all may have a cost, especially if you're running all your infrastructure on the cloud. Each extra piece of information you include in your message, the fatter you make it, the more rich you make it, can add up to your costs, right? If you're running on-prem, okay, perhaps you could do everything as a fat event, and you will reduce your network calls and stuff like that. But again, it depends, okay? So be wary, because this can really add up, especially if you're using some kind of cloud messaging service. Another way to mitigate these kinds of issues is to separate what kind of messages you publish to the outside world and what you keep to yourself, okay? So if your system is so complex that you also need to publish events for your own consumption, so if you want to process stuff asynchronously and you want to publish out events that will only be consumed by your own, let's say, subdomain or your own service, what kind of, how rich would you make these messages? Typically, if you consume messages that your own system has produced, you have access to the same database. You might even be in the same memory process, okay? So you don't really need to push all this information. This information is already practically stored in your system already, okay? So if you just want to do some kind of asynchronous processing within your bounded context, within your subsystem, it doesn't really make sense to publish too much information. Now, if you're publishing events for some other consumers and you want to avoid having them call back with an extra HTTP call or requesting extra information for everything you publish, it might make sense to go with something more rich. Now, the good thing is that using some kind of these techniques can also play a role in how easy it is to evolve your schemas. So, for example, if you go for an envelope kind of message, it allows you to version your metadata and your actual message schema at a different rate, okay? And it really, can provide more flexibility. The good thing about the envelope pattern, and especially with tools nowadays that support it, is that you can actually do smart things like having thin events within your domain and then enriching the outgoing events via some kind of messaging gateway or at the publisher level. Or you could use more rich events within your system, and then when you want to publish stuff to the outside world, just do some kind of anti-corruption layer that removes some of this information so that it's not exposed to the outside world, okay? So the good thing about modern platforms like messaging gateways like EventBridge, for example, is that they allow you, as they're aware of the cloud events, for example, envelopes, to do these kinds of transformations easily without needing to write any code, okay? And this is similar to what we do with HTTP requests using an API gateway that does these kinds of transformations on the responses of the requests and things like that, okay? It's quite an analogous situation. So beware, this is another area that needs your attention. Now, there are some questions you can ask yourself regarding how to choose one or the other style. We mentioned some, like the pace of evolution of your schemas, whether you use a single broker or multiple brokers or messaging systems, if you need some kind of strong schema compliance and you use some kind of schema registry or not, whether your messages need to contain routing info or your messaging system supports this kind of complex routing, okay? Whether you have message ordering requirements. These are all aspects that you need to be aware of before reaching a decision. Now, we're getting to the causation ID part. So how many of you have used a tool like Jaeger or any kind of tracing system? Okay. Okay, so these systems are very nice. Sorry. Yeah, good idea. These systems are very nice, and they really, can give us a very good idea of how our systems work, okay? Especially in a microservice environment or, some kind of distributed system, whatever. However, when messaging is involved, they really fall short, okay? And it's not that they're bad at what they're doing, it's just that they weren't designed to do that, okay? So the standard W3C trace context that contains actually the three elements, the trace ID, the span ID, and the parent ID, was created to be able to, let's say, track communications that are synchronous, like request-reply protocols like HTTP or RPC, okay? So they have this idea that there is a single tree, and this has different spans for the different kind of operations that are performed for a specific request, okay? And it's the top-level node, the parent node, contains, let's say, temporally, all the operations of its, all the child operations, okay? So all the operations must occur within the time limits of the upper, let's say, node. But messaging breaks this model. Because actually what we get with messaging is that we temporarily decouple the producers from the consumers, right? If I produce a message and leave it on a message broker and it lies on a queue, I could process that message and I would consume it like days later. Especially with systems like Kafka, where messages can be retained for a long time and you can process them again and again, okay? And you have multiple consumers for the same messages. You can't really depict this in a single tree, okay? And it also doesn't support operations when you need to have some kind of batch operation, when you would need to have like an operation that is occurring at the end of the day, for example, when you need to process all the transactions of a single day, Okay? Anyone seen how the zeta mechanism works in cash registers? At the end of the day, you need to create this receipt about all the transactions that occurred that day, right? So if we were trying to model this and track this, let's say, correlation, this flow between different systems at the end of the day for all these messages, we can't really represent that. And let me show you an example using this diagram. So this is a good scenario where we have like some action, some HTTP request, for example, and this can lead to database queries or calling other APIs, doing other calls and stuff like that, or publishing some messages, whatever, okay? But the thing is that the parent, let's say here of this tree, contains all the different spans that are lying underneath it. So all these are different operations that take some time to process. They can happen in parallel, okay? But the thing is that they all can attribute to the same parent. There is this hierarchical, let's say, relationship where every element has a specific parent, okay? Now, if we're talking about a message-driven architecture, this really can't represent what would happen if we have some other process consuming some message 3 days later. Because then, if we want to put it all under the same tree, the whole tree that would be created under this new message being consumed would also need to be underneath the span of the process that created this message, that produced this message, right? So many tools, even expensive observability platforms, can't really handle these kinds of information, these kinds of tracking. This is a more complex example when we have, again, some kind of HTTP call that needs to handle some command. And you can see that it may publish some messages, and it's also consuming some messages. And what you're actually seeing here is that all these things under this consume message stuff, and all this is another tree, and all this is another tree. And this diagram is like 3 times higher than what I'm showing right now. This is happening because actually these are asynchronous consumers that need to handle messages that were produced by some other, let's say, operation up higher. And this cannot be displayed in a single tree, okay? This operation might happen very close. There might be some time overlap. But this whole operation under this message consumption could have taken place like 2 days later, okay? So even expensive observability platforms like the one I'm showing here, I'm not going to mention the name, can't really identify what is the parent node for all this. So we have tried to solve this problem essentially using what we call causation IDs. Now, what is a causation ID? A causation ID is a pattern that was first mentioned in the event sourcing community. It was actually mentioned by Greg Young, who is considered the father of event sourcing. And it refers to the identity of the actual immediate parent of an operation. Okay, it's not like the trace ID we have in HTTP calls where all the operations are correlated under it. It's just the parent, the immediate parent ID, the ID of the, let's say, the message that caused this operation to take place. Okay, now the correlation ID is also used back from the days of enterprise integration patterns, application patterns. And it was mentioned in Martin Fowler's book, I don't know if anyone has read it. A correlation ID is used to track the entire conversation. Okay, so it is actually synonymous nowadays to what we have with W3C trace context as the trace ID. Okay, and modern observability, let's say, frameworks like OpenTelemetry can now support this causation ID tracking using what we call span links, which defines a causal relationship between 2 different spans, between 2 different, let's say, trees, but without having to have a single parent, okay? So this can represent, in fact, fan-in operations or batch operations or operations that would span days or would not be represented under the same parent. To make this more clear, I have an example here. So, typical scenario, order creation. We have a message that says a command here. Commands are in blue, events are in pink, in magenta. We have a create order command here, okay? It says I want to create this order. We don't include right here the order details. It doesn't really matter. But we have a message ID, a correlation ID, and the causation ID. So these are all metadata that travel with our messages, okay? This is the unique message ID of this command. So it's like starting a new tree from which the whole process will be beginning. The correlation ID is what will be used to track this entire flow across all systems that somehow need to be informed about this order, okay? Now, this operation, this command was issued after, pressing a button that says, okay, check out this order, okay? So it has no parent, it has no causation ID. There was no other message that caused it to be published, okay? Now, at some point in time, we process this command, we handle it, and we issue an event, we publish an event about the fact that this order was created. Now, this order created event will have its own message ID because it's now starting a different span, a different tree, okay? It will have the same correlation ID because it's all about the same business flow, but its causation ID will now be the ID of the parent message, of the message that caused it to be published, okay? So this allows us to build this kind of causal chain between the different messages that travel in our system. Again, when we have some consumers that consume this order created event, we have one in the, let's say, finance department where we need to publish the invoice for this order, and another for the shipping department where we need to ship this order. So these are all new commands that were created as a response to handling this order created event, right? So we had two different consumers of these events, and they represent the action that needs to be performed on their subdomain as a different command. So we have a publish invoice command here. It has a new message ID. It's a different process. It's a different department. It could be a different microservice or a different, I don't know, some other part of the world, whatever. But it still has the same correlation ID, and its causation ID is the message ID of the order created event here. Okay? And this thing goes on and on. So this is like causation IDs, as they are, translated into W3C trace context and OpenTelemetry span links, are what allows us to build this causal chain for complex, let's say, workflows where we have multiple business processes triggered in different subdomains, in different services that actually actually involved with the same business transaction. Okay? Make sense? Great. So, what we do to map these two, let's say, systems, these two mechanisms, is we use correlation ID to map to trace ID from W3C. Message ID is the span ID, and the causation ID is the parent ID in W3C. Okay? Now, are we good? Okay. Enough for the technical stuff. Okay? Perhaps we didn't dive into the code, but you get an idea that this is all stuff we deal with at the code level or at the, let's say, engineering level. Now, the approach we select can also be affected by more than technical, let's say, aspects. So, Conway's law, everybody's heard it. You heard it mentioned here in this conference again yesterday, and perhaps today again. What this says that actually the systems we'll build are not just technical. They have social aspects. So, effectively, the structure of organization affects the communication flows within that organization. So if we have a different department for sales and procurement and shipping and inventory and whatever, these all need to somehow communicate to perform their business tasks. So there will be some communication flows between these, let's say, different departments. Okay, and this is how you can accidentally, if you're not aware of this, let's say, universal law, push your, let's say, company structure into the design of your systems. Okay, you're actually pushing. You have the HR acting as the architect for the systems you build. Okay, so again, based on the structure of the organization you're in, this can play a role in what you should prefer, what kind of approach you should prefer for your messaging between these systems. When working in a siloed organization where departments need to work independently and there's not so much collaboration, or we need to set strong boundaries between teams, typically we need more explicit contracts, more clean interfaces, easier versioning of our schemas, not exposing too much information to the outside world. So what kind of messaging style would you prefer? Yes. Okay, it can be a lifesaver here, okay? Now, on the other hand, if you're like in a more cross-functional organization where you can collaborate or you can have shared ownership of the stuff you build, this typically can work in a smaller, let's say, organization when the boundaries are not really very, very solid yet. So when you can actually share all the patterns and you're all writing on the same code base and everything, it can, I mean, what would you choose? I mean, it would save you a lot of trouble. Exactly. Okay. Of course, this may vary. Okay. It's not like there's no clear-cut decision on this. There's no definitive answer. Governance is also a big thing and can affect how you make these decisions. If you have like this centralized governance where you have this core, let's say, architect team or some other people, let's say, are responsible for making these big decisions that could affect you, okay, and technology choices about what kind of infrastructure you will be using are top-down and kind of enforced on you, then you could leave someone else worry about many of these aspects because theoretically you would have such a structure in place that would be able to guarantee that you have all the necessary support to deal with only your strict domain concerns. Okay, right? So what would you consider as the best fit for this kind of scenario? Pure again. Okay. Again, it may vary, but in this scenario, we guess that someone else has taken the time to do the work needed for us to be able to only focus on our domain concerns or strictly on our business concerns, right? It could be considered like an ideal scenario. It doesn't really happen very often, at least in my experience. Now, when we have a federated governance model where you have different islands, let's say, different teams making their own decisions, but you have some underlying principles that are shared. So each team, each vertical, each, let's say, subdivision can make their own decisions about specific technologies, but they all need to, let's say, agree on some standards. And you have communities of practice that are focused on specific technologies or whatever. Then I'd go for this kind of style, okay? Using an envelope kind of style here can really help, build this baseline for collaboration. You know that you have this agreement on what kind of metadata, for example, you will be exchanging across all departments, all services, no matter what kind of broker you use, no matter what kind of, is your core domain. But this makes things more interoperable, let's say, okay? And in the case where everything is decentralized, each team is working autonomously. You don't have any kind of shared infrastructure. Anybody can choose can go their own way. Come on, it's an easy one. Bugatsa? I'd go for this one. But I mean, okay, of course, the envelope would work well as well. But if there's no governance at all and everybody's, doing whatever they like, you could end up in such a situation, okay? Okay, I'm not gonna spend more time on this. I will just stick to these questions for validating your approach. So, what you need to keep, just a moment. Yeah, sure.
Very scalable.
It's a very valid thought, yeah. I mean, this decision framework I'm discussing here is not really, there's no clear way to answer these questions. But this could be like a red flag. If you notice that you want to include lots of stuff in your messages and have everything contained in them, including the metadata and stuff like that, then perhaps it could be a red flag to see that you need some kind of abstraction there, some kind of envelope or something like that, okay? So it depends on the maturity of the team. It depends a lot. Okay. Okay, that's a very nice question. Okay, so our friend here is asking, since we really don't really know what's going to happen, how our system will evolve, and we don't really know our domain very well yet in the beginning, wouldn't it make sense to go with an envelope approach that gives us more flexibility? No one will ever blame you for following this kind of approach. The thing is that usually, I mean, if you're in an organization for a long time, you usually see all these kinds of different styles coexisting. Because usually you start with something simpler, then all this trauma that I mentioned leads to going the other way and just stuffing all the stuff you can in there and going like trying to be as explicit and as detailed as possible. And then you kind of realize that, okay, why am I copying all this boilerplate with all the metadata again and again and doing like common base classes and stuff like that? It makes no sense. And you realize that a better abstraction like the one that Envelope provides could be a better thing. But typically, migrating from one style to the other has some kind of effort. And especially where you're in a startup or like you don't really know how your system will evolve, you don't have the time, you don't have the resources, perhaps, to do this kind of change, okay? So if you want an advice, start with Envelope. That's what Cloud Events really is helpful. That's why I'm all urging you to take a look at this specification. It might save you from a lot of trouble down the road, okay? I'm not, saying you should adopt them, but it's a good idea, okay? Now, so whatever kind of style you decide, or when you think you have outgrown the pros and are reaching more towards the cons of each approach, you could validate your selection, your approach, using some kind of questions like, what happens, do I have the skills to support this? What happens if my system overnight grows 10x in traffic, or if I need to scale so aggressively? And how should I approach the task of migrating to a different style. Okay, so these are kind of things you need to ask yourself. They will inform your decisions in a better way, right? Okay, and I have some examples just for this case you mentioned. So if you're in a startup and you have like 2 or 3 developers working on the same desk, let's say, you don't really need to spend too much time on infrastructure stuff or these concerns. You can keep it as simple as possible, okay, and avoid any extra complexity. But you need to accept the fact that you might need to have like pollution of your domain code cleanliness or purity in favor of development speed, okay? So you could go for an embedded style here because you won't really be carrying all this information. You might not even need to have asynchronous processing and microservices and stuff like that. Okay, so this might not be even a thing for you. Now, when you start to grow and standards start to evolve and some people want to try new technologies that might fit their case better and you start forming these, let's say, subdomains, an envelope could, it won't really be very difficult to move to an envelope format then, because your system won't be that big. Okay, it's just a couple of teams. So you could, pay the price. It's a good point to pay the price. If you leave it for later on, it's going to get more and more difficult. Okay. So, of course, the migration will be painful. Of course, there will be, a need to level up your skills and, learn new stuff to be able to do this, but it's a good investment because you already get some traction in your product, so it makes sense to invest in the technical stuff. Now, when in your enterprise, that means you typically have like all the platform engineering available and all the stuff is already taken care of for you somehow, okay? And it's somebody else's concern to provide all the building blocks for you. So you could only deal with your specific domain problems to solve. So perhaps you could consider the pure style again. But again, it depends. It depends if you have integrations to third parties. It depends on a lot of stuff. Again, an envelope would be a solid choice, okay? So, I'm leaving you with some takeaways. Each style has its, let's say, good parts and bad parts. So, depending on your scenario, there's no clear-cut answer. It's not just the technical stuff that we need to worry about. So all these messaging systems out there somehow support, propagating some kind of metadata with your messages. You just need to change the mechanism on how you do that. But the social aspects also play a big part, like the maturity of your team, how your organization is structured, what kind of communication flows exist in the business. These all take a big part of our daily, let's say, decisions. So keep it in mind. And of course, evolution is something that will happen, so we need to plan in advance if possible to avoid the extra pain. Okay? And of course, if I can suggest something, it's to measure the impact of all these decisions. All these different styles, all these different decisions have an actual impact on the developer experience. And not only on the developer experience, on your speed of delivering features and your ability to adapt to your, let's say, changing requirements. Okay, some of these make it easier, some of them make it harder. Depending on your maturity and all the other aspects we discussed, you can decide on one or the other. Okay, so that's all from me. We're a bit early. I skipped some, let's say, code parts. You can stick around if you want to go through the code with me, or we can wrap it up here. It's up to you. Okay? Any final questions before we dive into the code with whoever is interested? Okay, I can show you. Okay. So, in this demo project I have created, you will find two implementations in the infrastructure folder. One is for Kafka, the other is for RabbitMQ. Let's open the Kafka one because it's a bit simpler in terms of implementation. So for the publisher, okay, I have built some kind of abstraction so that you can, make it easier to add new, let's say, functionality or extend your functionality. So you will have some virtual methods here and stuff like that. The idea is that what you need to, when you need to publish a message, you need to somehow, if you don't already have this metadata explicitly passed in as the message you want to publish, and it's not something that is filled in your domain, for example, if you're using the embedded style, you somehow need to create it so that it accompanies your message, right? So you have your payload, and your headers here is in Kafka what we use to propagate this metadata. And somehow you publish this, you produce this message. Okay. Now, depending on the message style, what differs is only where you will extract this metadata from. Like, how would you know what to fill into the causation ID or correlation ID or stuff like that? So this depends on the kind of messaging style you have selected. In the case of an envelope, you have this information as the metadata part. In the case of the embedded messages, you have this in the message already, so you can extract this and add it as headers accompanying the message. And in the case of pure messages, you somehow need to create it yourself. This requires some kind of magic, okay? So it's easy to create a new correlation ID for outgoing messages, but if you somehow need to add this causation ID to be able to track the original source of the ID of the, whoa. Sorry, guys. Yeah. Yeah, sorry. Things happen in live demos. So effectively, you would somehow need to extract this information and pass it along to your producer. And there are many ways to do that. But in any case, in order to, when you want to use the Cloud Events envelope, the only thing that needs to change is that you need to, let's say, overload the part that creates the actual payload of the message. Okay, so you just have this library for Cloud Events. There are libraries for many different programming languages, and based on that, the only thing you need to write on top of your existing implementation, for example, is the thing that will translate all this metadata to the envelope that Cloud Events specification defines. So by using some kind of SDK for your programming language, it's very trivial to do. Let me log in and open up the code again, and I'll show you. So in this example, for example, if you open up the implementation, you will see that to support Cloud Events, I just needed to overload the method and add and use the Cloud Events envelope format. Nothing more than that. Now, to support the cloud events variant, I just overloaded a couple of methods, and instead of publishing the original payload, I use the what is called the cloud event envelope, this class that this SDK provides. And you will see that, as I mentioned, as per the specification, some attributes are mandatory and they need to be filled in every cloud event, like the ID and the type of the message, the source, which is the service that created this message, the timestamp, and the content type. And then you just add your message as data, payload, and you use the serializer provided by this formatter, this cloud events serial formatter to format your messages. Or if you, this is for the structured format. If you go for the binary format, then effectively you can use different formatters based on the kind of protocol you want to use, like protobuf or JSON or whatever for your payload. But it's all the attributes and the actual payload are included in the same message. It's like opaque for Kafka. It's just a byte array, for example. Okay? So it's very trivial to just adopt it. If you have like an infrastructure and you already have like kind of an envelope class, it's very easy to adapt it to use cloud events. Okay? If you give me a couple of minutes, I can also do a demo of how to run this project if you want, or we can go through any other parts of the code you'd like.
I have a question.
Sure.
I saw that. Okay, the question: what type of IDs we can use for correlation ID and
What kind of
causation ID?
types?
Yeah, I mean, I saw that somewhere, most probably, GUIDs. You used GUIDs, but can
Yeah,
we
you can use any kind of strings or GUIDs or whatever you prefer. There's no specific, let's say.
Are there any good practices?
It depends on what your team prefers. There's no strict rule. Like even a GUID can be translated to a plain string. So yeah, UUIDs is a good, let's say, practice anyway. So okay, so if you want to run this this demo project, I have provided a Docker file, a Docker Compose file that you can use to start up any dependencies, and you can actually see the messages flowing. Let's wait for the different components to start to spin up. Okay. Now, what you will see in the demo let me see if I can increase the size. Okay, so this is the demo runner. It allows you to select a messaging style and the kind of broker you prefer to use. So let's go for the pure style for RabbitMQ broker. And it runs all the different scenarios that we mentioned, all the different tasks in the scenario we have. So for example, you can see some logging here about the consumers starting up and the producers and all these things, all the infrastructure being set up. I haven't split it into two different processes, like a different producer and consumer application. But I mean, we could do that. I just spin it up as a single application. They don't communicate directly. They only communicate via the broker, the producer and the consuming side. So it makes it a bit easier. And can you read the text? Is it visible? Okay. So I'm trying to run the social media post flow, let's say, task. So I'm starting with a basic post creation, which will demonstrate how we're handling a command that will eventually lead to publishing an event. And this is my command. It's a create post command with this ID. If you notice, it's a GUID starting with A1 and ending with A1. And we have all the different information there, like the content of the post and the timestamp and stuff. This is just the domain model we have for the command, as I displayed in the earlier. And we're sending it out, we're publishing it, and we have some consumer that's consuming it. And this is, but actually this is the event that is created. When we handle this command, we're publishing this event as a response, okay? And you will notice, this is the post ID that we created, this is the author, and this is how we propagate this information. Now, in this style, as you will notice, I don't have any information in my event on what was the command that led to this event being published, right? So I can't really know, if I see many of these events, I don't really know what's their, why they were published. Okay, this is what I mentioned about losing the opportunity, losing the ability to identify the whole chain of interaction and the flow between systems. Because they would typically be different systems, perhaps, okay? And yeah, we can move on to next one. So this is the task for adding a comment to a post. Now you will notice that this is not always a one-to-one relationship. For example, as I mentioned, by handling a command, this can lead to publishing multiple events, okay, that perhaps have the same or different recipients. So adding this comment on a post is leading to two events, the comment added event and the notification created, which would be the fact that the original author of the post that received the comment should get notified that there is a new post on a new comment on your post, right? So this is something that involves, this event involves the original author of the post, but the comment added event is something that could be interesting for other parts of our system, like, for example, something that calculates your statistics or, you know, keeps track of your engagement with the system and stuff like that. Okay, these are directed at potentially different consumers. Okay, but you have the opportunity to build this kind of complex flows where multiple consumers can listen to different types of messages, all published as part of the same business conversation, as part of the same business flow. Okay, and yeah, then the next example is about reacting to a comment, to a post. Again, we have a notification. We have an event for the post reaction that was added and another for the notification that needs to be sent again to the post author. And then another example about establishing a relationship between two users. This is a bit more complex because when we accept this connection request, we need to notify both the sending party and both the requesting party and the accepting party that the connection was established, for example. Okay, so we get more events published, more notifications sent out and stuff like that. Okay, now this is all the flow that you can use. The nice thing about running this demo project is that it actually uses local containers for your brokers and does all this communication. So you can, if you go through the code, you can see how it works in practice. Now, I'll do a demo with the Cloud Events variant, again with RabbitMQ. Let's keep it simple. And, okay. Now again, as I'm posting these messages, as I'm creating these events and stuff, you don't see any messaging infrastructure concerns leaking out, right? Because here I'm dealing with an envelope that has wrapped both the metadata and the domain message, the actual event or command, but I don't really need to care about the metadata if it's not something that I need to, if I'm not writing the abstraction layer for the broker. This information is carried around with the message, but my business code doesn't really need to know about it, okay? So in the end, you won't see anything different. And it's the same with the other ones. But if, for example, I try to do this with the embedded style, in order to be able to support this, I will need to deal with all the extra information. Sorry?
I think you chose envelope again.
No, I chose embedded. Oh, shit, yeah. Sorry. Come on. Okay. So let's go with envelope, it's number 3. Go for RabbitMQ. So you will see here, even from this point on, that now you're subscribing to an event envelope of some type of message, right? So, oh, sorry. Again, I chose the envelope. My fault. See, I'm so used to using envelopes these days that it's natural. Okay, let's go for the embedded. Okay, now you will notice here that I include within this message all the different stuff, like the message ID, the correlation ID, the causation ID, which is the ID of the initial post command, timestamps, and stuff like that, right? So in order to be able to support this kind of functionality in this chaining, I need to do it manually and update the values of these attributes by hand. And it's not really very, very easy to do, okay? And this goes on and on. So the idea is that when you're handling the top level, let's say, command that is starting the whole business flow, you create some kind of correlation ID, and all the other consumers and producers that might be triggered, all the other business flows that are triggered by this operation, if you want to be able to keep track of what was the real reason that they occurred, you need to be able to propagate this kind of correlation ID together. And you can do this either by manually adding some kind of correlation ID field in your messages, or by leveraging what OpenTelemetry gives you, or what W3C gives you, or any broker can provide for this kind of mechanism. Okay, but this all is different for the developer. It provides a different developer experience, and it can make things easier or more difficult to break. Okay, any questions? I hope it wasn't too technical. Yeah.
Regarding the example with accepting the request,
Mm-hmm.
what's the position ID on this example? The one that accepting the request or the one that reads the request?
When you let's see it here. Okay, so we're in this case here. So we have an accept connection request command, okay, and it has this ID, and we have an event that says connection request accepted, and they have a notification that says, okay, this was an accepted. If you notice the messages here, this notification is targeted towards the sender that says, the recipient accepted your connection request, and the accepting party has this different message that says that you are now connected with this user, right? So if you notice, all these messages have the same correlation ID, but the causation ID is different, right? And all these messages start from handling the original request. Okay, so if it's a bit tricky to track now the different IDs. So this.
No, they're not all the same. The notification created event, both of them have the same possession ID. Because they
Right.
have the same
Both these events started as a result of the first, or the first action of the command handling. Okay. Yeah.
I have a question, but maybe it's too late.
Oh, it's okay.
So it looks like that the producer sends messages to the consumer,
Mhm.
assumes that message would be
Okay, that's a very nice question. Again, it depends on your domain. It depends on how critical it is. You know, if some message wasn't consumed or the consuming party wasn't able to process it, right? So you might need to have some kind of business remediation, let's say, process or recovery kind of way. Or if you could have a retry because, for example, perhaps some information wasn't persisted yet, and you need to try this operation again, and it might work in the next second or something. So there's lots of different ways to tackle these kinds of situations.
Can we assume that there's a channel going back that the consumer is now producing?
If you design your system in such a way, yes, that could be. It's not necessarily the case. What you typically want to make sure is that you somehow ensure that your messages will reach the broker so that there is a chance that the actual consumer will consume them. And you typically do that using an outbox pattern or something like that to make sure that you're actually writing the message to the broker. So that if, for example, you're producing site crashes before you reach the broker, this message will eventually reach the broker. And on the consuming side, there's lots of different ways to handle. There could be transient errors for handling a message. There could be like permanent errors. There could be business validation errors that don't allow you to consume a message. So it depends on how this, let's say, receiving domain, this consuming domain, will need to respond. It's a matter of business decision. Okay, they may need to have like a different channel, as you says, that notifies the original, let's say, publisher that I wasn't able to process this order or whatever, or there might be some kind of other business process that involves people in the way. Okay? Okay.
Putting aside the outbox pattern and the distributed transactions, is there any other way to ensure that a transaction will commit and a message reaches the broker?
Well, it depends on the broker. For example, Kafka has this idempotency feature on the Liberty Kafka library that is used to integrate, to connect with it, which allows it to keep trying to send a message to the broker if for some reason there's a transient error. But again, if you really want to make sure that it has actually reached the broker, you need to check the acknowledgements attributes in the configuration of the library and handle any errors that it will return if this operation fails. Configuration plays a big part here when interacting with the broker because, for example, by default, the Kafka library will try to resend a message for up to, I think, 30 minutes or something like that, but it won't give you an error immediately, right? So if your process crashes, you might lose a message. Okay, that's why reliable publishing via an outbox is a best standard, is a best practice nowadays.
Thanks.
Okay, thank you all guys. If you have any more questions, just meet me later.